application might introduce to the organization. So don't use defect density as a metric for measuring risk. What it is good at is determining the kinds of mistakes we make most often. So our developers are having a real trouble with SQL injection. Let's go give some targeted training and focus on that kind of vulnerability because it's the most common right now. Another thing that it's good at is measuring what is the remediation effort involved in fixing a given vulnerability. So you look at the density of a given class of vulnerability, you look at how long it takes to fix them, and you can start to get an idea when you do a new scan of a project you haven't yet audited, what's it going to cost to fix. We have this many SQL injections per 1,000 lines of code. That's going to take much more remediation than this many cross-site scripting vulnerabilities. So some parting thoughts, and then maybe we'll have a few minutes for questions, actually. We build our software on top of various building blocks, languages, libraries, platforms, and so on. And most of these have security problems in them. Many of the issues we face today come from flaws that really should be fixed elsewhere. They're part of the, buffer overflow is really a flaw in the C language. SQL injection might have to do with the APIs that Java or an ORM like Hibernate provide to the programmer. But we're not going to fix the problems at that level. We're not going to solve the problem. We're not going to be able to solve the problem by waiting around for other people to solve the foundation that we build our software on. So we have to concentrate on techniques for enabling non-security experts to make the right decisions at the right time on top of imperfect building blocks. And really the key is learning to get our software right even in an imperfect environment. So in conclusion, mistakes happen. We should plan for that. The idea that we want to, the quote from the Petrovsky book, success is foreseeing failure, doesn't mean we're going to be able to prevent failure in the future or eliminate the risk. But we can take steps to diminish the risk and mitigate it when it does, or mitigate problems when they do occur. Anybody today who says that security is not firmly in the realm of programming and a problem for software developers is living in the past. Firewalls, network security, security features like crypto aren't going to solve the problem for us. We have to adopt it as software developers. Tools have different benefits for different consumers. So for an auditor, a tool makes a manual process much faster. They make them more effective at their job. For a developer, the biggest attribute of a tool is the ability to bring that security knowledge, all the specifics of security that change monthly at least, along with it, and in conjunction with a little bit of training and education, make them better able to make the right decisions at the right time. Finally, what are some critical attributes of a good tool? Make sure that it has the right algorithms to find the vulnerabilities you're interested in, the right rules to, the right algorithms for the classes of issues you're interested in, the right rules for the specific vulnerabilities you're looking for, a good interface, and the right kind of plan associated with it for implementing it, putting it into practice. This last one is where we see most people fail most often. They get the whiz-bang new shiny static analysis tool, and they throw it over the fence, and then it falls on its face because they don't have the right training and process and techniques around how it's going to be applied and how they're going to deal with the work that it generates. Because again, it doesn't solve the problem for you, it makes you better able to solve it yourself. With that, I'd like to open it up for questions. Does anybody have anything, I hope?
I have a question. You mentioned embedded systems.
Certainly.
If you have a device that's not networked, what kind of vulnerabilities do you see or risks associated with those kind of systems?
So a lot of the concerns we face come back to input. And just because it's not coming remotely over the network doesn't mean it's not input still. So embedded systems, one example is we talked to a company that was building cable decoding boxes, set-top boxes that decode premium cable content. So they're not particularly concerned with the stuff that's coming over the wire because they know who's on the other end of that content. But they are concerned with what if someone hooks up electronics to our board and starts providing inputs manually? Or what if someone mashes the buttons in a special way? So a lot of it still does boil down to where does the input come from, who's interacting with it, what are the threats?
Another question. We got several minutes.
Yeah, we can't possibly end that early. I was worried I was going to run out of time, so that's why now we ended early. You have to ask some questions.
You're the first one to actually end
Maybe that's because my last experience was being like, you know how they start playing at the Oscars? They play the music and have the big cane and haul them off stage? That was the last talk I gave, so I was trying to err on the side of short.
You talked of Matrix as not a replacement for the tools.
Sorry, as what is not a replacement?
Not a replacement of the statistics tools. So, but do you see them in conjunction with the tools? I mean, what I'm trying to say is that Matrix is probably what tells the company, what tells the application owners to work along. I mean, Matrix can identify what the problems are, but they can't solve it. But Matrix actually tell you how to focus on the 80-20 rule.
Yeah, absolutely. I think metrics are most appropriate for targeting your efforts, because you're not going to be able to solve the whole problem immediately. So find the areas to focus, and as you said, 80-20 rule, absolutely.
So they're probably the conjunction to the tool.
Yeah, certainly, certainly.
Anyone used a static analysis tool?
What did you use?
Competitors clockwork.
Yeah.
Yeah, I used it over the summer.
On what
Embedded systems.
makes sense? Were you focused on security, or you're just looking for bugs in general? What was your experience with it like?
I really enjoyed it. Another guy started, his project was QA, so he was overloaded at the beginning, and I just started a new project.
Excellent.
How big is Fortify?
We're about 140 right now. About 300 customers.
How old?
5 years, a little longer.
You've been there for the whole time?
4.5. When I started, the whole company interviewed me in one day.
What were the credentials they were looking for?
I came from Berkeley, and I worked on a static analysis tool there. So I had I found out afterwards the optimal set of credentials, because I'd done just what Fortify does now. In general, we're interested in finding people who are excellent engineers, have experience with various kinds of systems, because we have customers who build everything from databases to web applications to the stuff that runs on an airplane. If you've got some experience with software security, that certainly doesn't hurt, but it's not a requirement, I suppose.
So is it a lot of compilers?
Depends on what you want to do. So the analysis team, the team that builds the analyzers for the tool, definitely a lot of compiler guys fall there. My team developing the security content, not nearly as much.
Do you recommend any tool for the program-based, for example, for Microsoft-based, they have FXCOP, so for .NET-based programs. So,
Well, I can't possibly recommend that, because we analyze .NET programs as well, but FXCOP, as far as free tools go, is a useful one, and it will definitely find interesting stuff. So if I had the choice between telling someone to use a static analysis tool versus no static analysis tool, then I would certainly encourage you to use a static analysis tool.
just because it's very free.
Yeah, absolutely, absolutely.
And it's simple to use. I haven't seen any of these static analysis tools from public, so concept.
Yeah, I think it's very useful.
And these also deal with the programming standards and stuff like that.
How do you mean?
Programming standards, nomenclature, naming conventions.
So that's certainly not these meaning tools like FXCOP or Fortify. We certainly don't, we're focused on security. So we're trying to solve the software security problem. We don't emphasize quality checks or style checks for the most part. That doesn't mean that we haven't built a lot of capabilities that are useful there. So we have some of those checks built in, and with some customization you can build many more on top of our foundation. But that's not where we're putting our research efforts.
And how do you see memory leaks out here in the, the current framework 3.5 or so? Microsoft itself takes care of the memory leaks, garbage collection and stuff. So why do you think there is a need still to focus on the memory leaks?
Not everyone is using the latest and greatest, and in fact,
2.0, I think they still take care of garbage collection.
so you're talking about managed C++ code, basically.
Yes.
So in my experience, I never see managed C++ code. All of the C code I see still are legacy systems that have been around for a long time. They can't be re-implemented, and now they're stuck in this legacy environment, and they're going to continue living forever. If you can write managed C++ and take advantage of some of the more modern language features, like a garbage collection, then fantastic, you've solved a big piece of the problem.
And it's not only managed C++, I'm saying any managed code, be it VB.NET.
Yeah.